station. This is Houston. Are you ready for the event?
We are ready for the event.
The Weather Channel, this is Mission Control, Houston. Please call station for a voice check.
Station, this is the Weather Channel. How do you hear me?
We read you loud and clear. How about us?
Ah, great. Okay, so I'm going to start you guys off with what is a day in the life on the International Space Station like?
We know every day here is pretty busy. We get up around 6 or 6:30, depends. Some of us get up earlier, some a little bit closer to our daily planning conference, which begins usually around 7:30. And then we're off to the races. We have a very full schedule of science, maintenance. We exercise for about 2.5 hours a day. And so that takes us all the way up to the evening daily planning conference, which is usually around 7:30. And in between there, we fit in photographs, maybe a phone call. And then at nighttime, it's really just catching up with the day. So we have a very full schedule up here.
Okay, so speaking of working out and photographs, I have to ask Tim Peake a couple of questions. First off, running the London Marathon, leave it to me to think, what happens to all your sweat when you're running? Or do you not sweat in space? Or what is it just like sweat all over the International Space Station?
Yeah, that's a great question. Well, firstly, yes, we do sweat in space, probably maybe even more so than back on Earth, because there's not as much airflow up here and it's a bit warmer on board the space station. But we recycle all of that moisture that we breathe out and that we sweat out. It all gets absorbed back into the space station's atmosphere. It gets cleaned, recycled, and we drink it again, probably the next day or maybe 48 hours later. In space, of course, the sweat doesn't work that efficiently. It doesn't drip off you. It just kind of pools in big globules. And for me, it kind of goes to the top of my head. So I'm constantly mopping the top of my head with a towel when I'm on a long run to get rid of all of that sweat.
Okay, so I want to talk about some of the pictures. And Tim, you took one of a little piece of dust that cracked the windshield of the space shuttle. It doesn't seem that you're in any sort of danger, but that seems like it could be pretty serious.
We do have some chips in the windows from small debris that's actually made an impact. And so when they design the windows and all of station, it's really designed with protection in mind. Our shutters cover up the windows, and so we open the shutters to take pictures, but the majority of the time they're covered with these very sturdy shutters. It definitely it speaks to the fact that we're in an environment here that has lots of hazards, but we do the best we can to mitigate it with the design we have of our space station.
Okay, to talk more about the pictures, you guys often take these phenomenal pictures of hurricanes from space or, the California wildfires. Are you aware of what you're actually taking pictures of? And also, are you able to give us any help and any new information from your perspective?
Well, I would say sometimes we're aware of it, sometimes we're not until we see the view out the window and we grab the picture. Obviously, we get some news up here. We get updates every day. If there's something big happening like the horrific fires in Canada, the ground will let us know and alert us to grab pictures. But oftentimes we're just in the window taking pictures of some part of the Earth, and we will observe something that nobody has let us know about, and we grab pictures and then find out after the fact what it is. And that has occurred with weather systems as well as volcano eruptions.
Okay, other things that you guys are able to see the aurora borealis, which is just mind-blowing, especially to see it from space. But I want to talk about the transit of Mercury, because we spoke with one of your colleagues on Monday about that transit. Were you guys able to see that from your perspective? I was trying to think about, okay, well, we're on Earth looking at, the sun and Mercury going across. It should kind of still be the same from where you're located too, right?
It would be. In fact, Jeff and Tim were looking into if we had any equipment on board that we could use to look at the sun and be able to see this conjunction, and actually we didn't. It's kind of unfortunate, but we actually have a great view up here, and so with the right equipment, we could actually see those kinds of things as well.
So what weather weather do you miss the most when you're in the International Space Station? Though I guess your friend Tim Peake there, rains some showers on you guys when he does his workouts, but.
Yeah, I actually, coming from the UK, I miss the wind and the rain. But no, in all seriousness, a nice breeze when you're running, I think that's fantastic, and that's what I do miss up here. So I'm certainly looking forward to getting back and just feeling the fresh air.
Okay, so let's talk about your, what the research is that you guys are doing on this mission, because it seems as if everything you're doing is preparing for Mars.
We know the kind of research we do on board is really broad spectrum. There is a very large component of our research that's designed for us to understand the effects of zero gravity on the human body. And so we do ultrasounds, we have studies of our eyes, and a whole variety of different studies that are helping us determine what does it take to stay in zero gravity for a long period of time. And that would prepare us for a journey to Mars. Anytime we're going to be transiting into an area beyond low Earth orbit, it's definitely necessary for us to understand, the impact of zero gravity. But there's also lots of other research that we do on board, lots of basic science and basic research, everything from combustion, fluid science, cellular biology. And so we have this world-class orbiting laboratory, and we hope to solve lots of those problems over time.
Would all three of you go to NASA? I mean, is that something that is of interest to you? Would you like to go? I mean, go to Mars. I'm sorry, I said NASA. My apologies, Mars.
Going to Mars, I'll speak for myself personally, that would be a little bit different journey. That would be a long way away, a long journey there. Of course, the work on Mars would be very interesting, but the whole mission would be very long. While you're en route to Mars, it's interesting. We spend a lot of time in the window here looking at the Earth, and the Earth becomes kind of the focal point of the unique experience of being here. But going to Mars, we would not be able to see anything except the sun. We couldn't even see the stars. So that would be a little bit different kind of journey. I think that's something potentially for the next generation.
You guys are currently over Ontario, Canada at the moment. Let's just talk about some of the basics for people watching of how many times you guys circle the Earth, in a day, and how fast you're moving.
So we're going around the planet every 90 minutes. That means we have 16 orbits per day. That comes out to 17,500 miles an hour, or about 5 miles a second. So, all of us love taking photographs, and it means you have to be really skilled, actually, for some of the close-in shots to be able to track and to get those photographs. But it's an amazing experience to be able to see the planet over and over from different perspectives, different lighting, and different areas on Earth.
So what is the favorite thing you have been able to see from the International Space Station in your time up there?
Well, I think every time you look out the window, as kind of Jeff alluded to there, you see something different, and everything is incredible. I've loved seeing the aurora, both the aurora borealis and australis as well, which has been really bright during this expedition 46 and 47. I love seeing thunderstorms at night as well. It's really spectacular, and you can see the huge scale sometimes of those thunderstorms over hundreds and hundreds of miles. And actually, in fact, it almost looks as if one lightning strike triggers a whole series of further lightning strikes, and they all go off together, which is really spectacular. It's also been nice over the length of time, having launched before Christmas, watching the northern hemisphere turn from a winter landscape into spring and now moving into summer. It's been great to watch that seasonal change over the planet.
Awesome. Tim, and Jeff, thank you so much. I have to say, this is a real treat for me. I went to space camp twice as a kid, so I am very much into this, and you've made my year. So thank you so much, and can't wait to talk to you guys again.
Thank you. It's been great talking with you.
Bye, guys.
See ya.
Station, this is Houston ACR. That concludes the Weather Channel portion of the event. Please stand by for a voice check from WISC-TV.
Station, this is WISC-TV. How do you hear me?
We hear you loud and clear. How about us?
Loud and clear. Good to see you guys.
It's great being able to talk to you today.
So, Tim, tell us about daily life on the space station.
You know, we have a very busy schedule here on Space Station. We typically get up about 6 or 6:30 in the morning. We have a daily planning conference about 7:30, and then we have a schedule that's very full every day, and it's comprised of doing science here on board, maintaining this world-class orbiting facility, and also exercising. And so we're really packed throughout the day doing all those things, and then we have an evening planning conference, usually around 7:30, and then the nighttime is really to have dinner and catch up on email and talk to family.
A typical day.
Jeff, you're a Wisconsin native from Winter, Wisconsin, and everyone here at home is so excited about this mission and following your mission. What is it like for you personally when you fly over Wisconsin, the Great Lakes, the upper Midwest? What does that feel like for you?
Oh, well, of course, it brings back a lot of nostalgia growing up there, and I've got lots of friends there still, some family in the area. I communicate with some of those folks. I love to take pictures and post them so that everybody can see that I'm watching them as well. I like to look into the details and see the lakes that I boated on and fished on and other journeys. I can even see my homestead from up here with a big lens and pick out the building. So it's a great experience, full of nostalgia, and fun to bring the experience to the people of Wisconsin.
What goes through your mind when you can see your homestead from 200 miles in space?
Well, I don't know how to explain it. I mean, it's pretty emotional to be able to see it and relive some of the experiences of growing up and knowing the people there and having that opportunity. Even sometimes make a phone call, say, "Hey, we just flew over, and I see you got your car parked in the driveway." That's of course a lot of fun to have with your friends.
Tim, what is the objective of Mission 47? Can you explain a little bit about what your goal is on this mission?
You know, all of the expeditions, to include Expedition 47, is really about fulfilling the potential of this world-class orbiting laboratory that we have. And so every day we're trying to meet the objectives that we have for different science experiments. And those comprise ones that are physiologically based so that we can understand the effects of zero gravity on the human body. And that will allow us to go farther, deeper into space in the future, and also, you know, mitigate some of the effects of zero gravity, negative effects really on the human body. And then we're conducting lots of basic science experiments, everything from combustion to fluid mechanics to cell biology, and really it's also a technology demonstrator. You know, our environment here is exactly what we make of it. The temperature, the quality of the air, everything that we have here on board is what we've created, because outside of the walls of this space station is a vacuum and not hospitable to human life. And so what we want to do is just advance the science and learn from this. And every expedition that's here on Space Station on forward will be doing the exact same thing, trying to develop the state-of-the-art in science and technology that will allow us to go farther.
Now, Tim Peake, the whole world watched you as you ran a marathon in outer space. How do you keep fit on the space station?
That's a great question. As Tim alluded to there, you know, maintaining fitness and health is really important to mitigate the negative effects of microgravity. So we do two basic types of training. One is for cardiovascular, because if we did nothing, our heart muscle would shrink. It has a really easy time in microgravity, pumping the blood around. Firstly, your blood volume reduces, and secondly, of course, it doesn't have to fight gravity. So in order to make sure that our heart muscle stays fit and healthy, we do cardiovascular exercise. That's on the CVIS bike machine, which is here right next to me, actually, and also we have a treadmill, a T2 treadmill, so we do running and biking. And then we have a machine called ARED, which enables us to lift weights. It actually uses two vacuum cylinders, because obviously weights up here would be meaningless, but using the resistance of that vacuum cylinder, we can actually do weightlifting and exercise the major muscle groups and try and prevent some of that muscular atrophy.
We can see you bobbing up and down a little bit. Do you have weights that are holding you down while you're talking to us?
You know, the three of us are actually stood here with our feet hooked underneath handrails. We call them handrails, but, you know, most of the time we move around the space station hooking our feet under things. And it's quite interesting because after 5 months in space, the bottom of my feet are completely smooth, you know, like a newborn baby. But the tops of my feet are completely hard and you know, hardened skin where I've been hooking my feet underneath handrails for 5 months. So we kind of use our feet in an opposite manner to how you do on Earth.
We see you guys have a lot of fun with this microgravity a lot of times. How hard is that to get used to?
Well, speaking for myself and also observing many folks up here, I think I've been on orbit with close to 50 different people or 40-some different people. And everybody adapts very quickly. Within the first few days or first couple weeks, you go through a huge adaptation. But it really takes about 6 weeks or so to fully get acclimated to the environment and working in 3 dimensions and not having to depend upon an up or a down to be able to work in any orientation and to be able to manage all the free-floating things that you're working with up here. After 6 weeks, everybody, I think, pretty much is up on the step and going strong.
Do the Russian cosmonauts speak English, or do any of the 3 of you speak Russian?
You know, we have 3 cosmonauts on board, and they speak good English. You know, you could ask our Russian colleagues if we speak good Russian. You know, we definitely attempt it. And so we ended up communicating really in both ways. We speak a little bit of Russian, a little bit of English. Sometimes it turns out to be Russlish, sort of a combination of both. But we all communicate very effectively. Our classes and training when we're in Russia are in Russian. When the cosmonauts come to the United States, they learn their classes and hear their classes in English. And so we end up compromising and finding a middle ground to communicate.
How many windows are there on the space station, and how often do you look out at them?
Yeah, we've got lots of windows on the space station, actually, because every hatch has a window in them. But the main windows that we like to look out are the lab window, which is right in front of us, and that's just facing directly down on Earth. And also the cupola window, which is actually 7 windows, making this cupola shape. And that's incredible. We can get sort of 360-degree views of planet Earth. Both of those are Earth-facing. We have just 1 or 2 windows in hatches which face upwards. And you know, that's where we can see the stars at nighttime. And also, of course, the Russian segment has a number of windows as well. So there are plenty of windows. There are also windows in our Soyuz spacecraft, which look out to the sides of the space station. So overall, we get a pretty good view most of 360 degrees most of the time.
Jeff, you're very active on social media. The pictures you post on Twitter are just spectacular. Is that an intentional part of your mission as well?
Well, thank you for the comment. Yeah, and I think I can speak for all of us. We want to bring the experience to the people of Earth because it is such a unique experience. And the best way to do that is through visual imagery, either photography or video. I have a preference, I guess, toward photography. I've taken lots of pictures every time I've been up here. Again, trying to capture some of the things that Tim alluded to earlier with the wide variety of objects that we have and things that we can see on the Earth, among them weather systems and geographic features and cities and waters and all of that. So it's mainly just bringing the folks on Earth vicariously to this vantage point.
Gentlemen, what a thrill to talk with you today. We're going to let you get back to work, and hopefully we can talk to you again soon.
Thank you so much.
Thank you so much.
It's been our pleasure. You all have a great day.
Station, this is Houston ACR. Thank you. That concludes the event.
Thanks.
Thank you, the Weather Channel and WISC-TV. Station, we're now resuming operational audio communications.